Hello, Algebra 1. Today we're going to look at 8.4b, finding the minimum and maximum values by completing the square. There we go. Probably a better name for this lesson is Vertex Form. Because how we're going to find the minimum and maximum values is by writing an equation in vertex form by completing the square. So we're still going to be getting a new C value. We're going to be taking our B value divided by 2 and then square it. We're going to get a new C value to complete the square. But we're not going to be solving these equations. We're going to have an X and a Y. It's going to be kind of interesting. We're going to write them in vertex form. Now, what's cool is you've got a lot of knowledge in your head that you got that we just need to recall on, and it's going to be kind of cool to do that. First things first, how do you tell if because we're going to be looking at quadratics, we're going to be looking at parabolas. How can you tell if a parabola has a minimum or maximum value? Well, if you remember, if a parabola opens up, it could hold water. And like a pool, you're going to have a bottom of the pool. So you got a minimum value if it opens up. If it opens down, it's like a mountaintop. And you've got the top of the mountain, and you've got a maximum value. Okay, so you're going to need to be aware of that today. And then you're also going to have to be aware, what else are you going to have to be aware of? Let's see. You're also going to have to be aware of vertex form and how to get there, okay? So let's take a look at an example here and talk about how we can do this. So it says find the minimum value of y equals x squared plus 4x minus 1. Because it's positive out front, this is going to open up. So we know that we're going to have a minimum value. They went ahead and told us that. But to find that minimum value, that's going to be at where the vertex is. Oh, maybe that's what I was trying to think of earlier. So your vertex. Well, just like yesterday, you're going to take the C value they gave you and move it over. Get rid of it. Because you're going to come up with a new C value. And just like yesterday, you're going to then balance it out on the other side. So to complete the square, you take your B value, divide it by 2, and square it. And in this case, you're going to get 4 when you do that. But then you got to balance it out on the other side. Once you complete the square, you can rewrite it as a binomial squared. Super quickly. And on this other side, we've got we got 4 and 1, they can combine. We've got a y plus 5. Well, class, we are so close to being in vertex form. All we got to do is subtract this 5 over, and our vertex form is x plus 2 squared minus 5. This is vertex form. And when you're in vertex form, you can get the vertex right away. So what we need to recall is that if you're in vertex form, your vertex is going to be opposite, because we learned that plus 2 moves the graph left 2, so it's going to be negative 2, and this minus 5 moves it down 5. Your vertex is going to be at 2, negative 2, negative 5, which means your minimum value is at y equals negative 5. So there's a lot going on here, but it's all in your heads. You just gotta recall the information, okay? It should be in there. For example, 2, finding a maximum value. Well, they already told us it's a maximum. But anyway, and then the reason why is because it opens down. So you're gonna have a maximum value. But to find it, you got to rewrite this in, the way we're showing you is we're gonna rewrite this in vertex form. So I'm gonna subtract this 7 over. Good night. And then we're gonna complete the square right here. So, well, but hold on a second. Do you guys remember yesterday I mentioned that you can't complete the square unless the leading coefficient is 1? Right now, my leading coefficient is -1. Now, yesterday, what I would have done is divided everything to get my leading coefficient as 1. But, I don't know. I don't know that I want to do that. I think it might be a little bit confusing at the end here. So what I'm going to do is I'm going to factor out a negative from this binomial. And then I'm going to complete the square and keep it balanced. To complete the square, I divide this by 2 and I square it. That'll be a +1. But here's the tricky part. I got to balance it out over here. But that 1 is going to get multiplied by a negative. So what I'm actually balancing out is a -1. Simplify over here. Rewrite this as a binomial squared, and we are almost in vertex form. So yeah, the tricky part here was we had to balance a -1. That was tricky because we had to factor out a negative first. And now to get it into vertex form, we'll add the 8 over. And our vertex would be 1, 8. And that would be a maximum of y equals 8. Okay, so vertex form, our vertex, our maximum. It's a little bit going on today, isn't there? Okay, so example 3 is just kind of a goofy sort of question just to see if you can figure this out. It says, which of the functions could be represented by the graph? Explain. And so this is kind of testing a lot of your knowledge here, seeing if you understand what's going on. I see that this graph opens down, so it's going to be have a negative out front. So that gets rid of this one there. I can see that its vertex is at a positive amount, and then it's positive going up. Okay, so here's the thing. This one's vertex is at -4, 8. This is clearly at the positive side, so I'm going to get rid of that one. Okay, this one opens down, has a vertex of 5, 9. I think this totally could be a possibility. This one is in intercept form. Its x-intercepts are 2 and 8, and it's opening down. 2 and 8. I think that could be where it crosses the x-axis, is at 2 and 8. It could be the x-intercepts. So those two are a possibility. All right, moving on to example 4. We've got a real-life application. It says the function y equals negative 16x squared plus 96x represents the height in feet of a model rocket x seconds after it is launched. Find the maximum height of the rocket. Well, class, the maximum height of the rocket will be at its vertex. So we're going to do vertex form here. We don't have anything to move over, so we're ready to think about completing the square. But before we get too far, remember, you can't complete the square when there's a number other than 1 out front. So we're going to factor it out. And 96 divided by negative 16 is negative 6x. Now we're going to complete the square, and we're going to keep it balanced. All right. Oh, yeah, I should complete the square first. Divide this by 2 and square it, you get 9. But when we go to balance it, we got to remember, we're not balancing a 9, we're balancing a 9 times negative 16. And 9 times negative 16 is negative 144. That's what we get to balance on the other side. Isn't that wild? So we're going to have negative 144 plus y is equal to negative 16. We completed the square, so we get to write this as x minus 3 squared. And our vertex is going to be negative 16. Y equals negative 16 times x minus 3 squared plus 144. That's our vertex form. From our vertex form, we can get a vertex of 144. And the maximum height of the rocket will be 144 feet. Pretty dang tall. All right, part B says find and interpret the axis of symmetry. Well, the axis of symmetry would be x equals 3. And what that would be is x is seconds after it is launched. That would be how many seconds it took to get to the maximum height. 3 seconds got you to the maximum because that's where the vertex is. So yep, after 3 seconds, you reach maximum height. All right, completing the square vertex form. Hope this helps you out. Have a great day.